Some really interesting 2040 boards have appeared in the market. This is particularly due to some great stock availability of the RP2040 chip compared with some other chips. I've used a few non-Raspberry Pi boards, including some dedicated network boards from WizNet. I think one of the most interesting, though, is the Badger2040 and Badger2040W from PIMORONI, combining the power of the RP2040 processor with a small e-ink display in an ID badge format. In this video, I'm going to take a look at the Badger2040 from a C++ developer's point of view. I'll take a look at its brother, the Badger2040W, in a later video. For those of you who have not come across the Badger2040, it's an RP2040 board, obviously, with an integrated 2.9-inch black and white e-ink display. That provides 296 by 128 pixels. It comes with some libraries to operate in C++ and Python. In addition to that e-ink display, you have 5 push buttons on the front. These are a pull-up to 3.3 volts when pressed. The switches are organised into 2 sets of A, B and C below the screen, plus an up and down button on the right-hand side. There's also a white LED that can be controlled on the front. On the rear of the board are 2 more switches. These are the boot select and reset button, primarily for the programming process. The main connection to your own electronics or modules is via the QWST socket. You also have USB-C connectivity, which can be used for communication, programming and power. The board is set up to be powered from a battery using the JST-PH connector. There are also some solder points, which include the SWD port and UART broken out from the RP2040. To power the device, we have the option of battery or USB-C base power. Battery power between 3 and 5.5 volts. There are examples of people running these off of 3 button batteries. Although you can use a LiPo battery to power the device, the Badger24 has no charging or management behaviour for such a battery. It's really designed for common or garden battery packs. Of course, you can also power it through the USB port. The main connectivity off the board is via the QWST port. This will give you connectivity to Adafruit, PIMORONI and other standard modules without any soldering or lead making. I plugged some generic I2C modules into the connector and have been able to use them perfectly. I did try to see if I could abuse the QWST connector and drive UART through it. Unfortunately, I could not get that to work. I suspect that's due to there being pull-up resistors on the data lines. We do have UART 0 available on the solder pads and SWD for flashing and debugging. I'm not greatly impressed with this being on solder pads. It's going to be hard for a hobbyist to put any sort of connector onto these solder pads. Though you could tack cables directly to these pads, they're not going to be very resilient. PIMORONI's online documentation is very much pushing users towards Python, yet they provide some really good C++ libraries for their modules, and the Badger2040 is no exception, though these could have some more comments and documentation included in my opinion. All of the libraries for their Pico products are in one repo. This also includes examples. I was a little disappointed that you could not easily build the examples from this repo. It took me a little work to be able to set up CMake to include the relevant libraries. The libraries provide graphic capabilities in terms of pixel drawing, line and rectangle primitives. You can also load images from binary structures and draw text in multiple fonts. The libraries also handle some of the other hardware, giving easy interfaces into the buttons and LEDs. I'm not sure I would use these, or whether I would be more likely to use my own interrupt-based button handling. There is some power management capability too, to put the RP2040 into a sleep mode, which then can be woken by the buttons. This is great on a battery-powered device. It also isn't trivial to configure, so it's nice that an approach to this is included in the libraries. I've put an example of doing a slideshow in the repository to go along with this video. This does the same thing as my YouTube 500 subscriber video. I showed in that video how to take PowerPoint slides and display them on the Badger2040. Text and fonts are handled nicely by the library. In this example, I just write out 2 lines of text. Sadly, the library doesn't include any documentation, and so you find out by experimentation that though the X position is to the left of the text, the Y is unusually in the middle of the vertical position that will be drawn. There's no easy way to calculate the text size, which would have been a nice feature. The draw primitives are straightforward to use. Pen color of 15 gives a white and pen color of 0 is black. Values in between are dithered. I set the line thickness to 3 for the example clock face. The clock face on the right is 5 minutes fast on purpose. Finally, the library tries to enable a sleep mode, where the Badger can be woken by pressing the buttons. I displayed a different bit of text depending on which of the buttons are pressed on waking. When the screen is updating, I observed up to 25 milliamps of current draw. During idle, this drops to 22 milliamps. But when you put this device to sleep, this drops right down to 2 microamps, which is great for battery life. It should be noted that the device does not drop into sleep when on USB power. Let me know what you think of the Badger2040. I'd be really interested. And thank you for watching. Please like, subscribe, and hit that notification button for more content from me. Goodbye for now.